Good morning, everyone. My name is Yuri and we're gonna do some live coding today. So just let me know if the video and sound quality is alright and let's get started. How are you feeling today? Where are you from? That part actually really inspires me when I see the vast geography that we have in here. Hey everyone. And while we are guten Morgen to you too. And while we are at the start, I want to thank everybody who supported me. Thank you all my Patreons. You're inspiring me to continue to do this. I want to apologize in advance because in the following 1 or maybe 1.5 months there gotta be some breaks in streaming, but I'm gonna do more write-ups, I'm gonna do more short videos, so I'm gonna keep you posted. Hey, India, Germany. I gotta learn how to say good morning in Indian, in Hindi. All right. Доброго ранку, доброе утро. So I prepared some wine to drink today, but then I thought maybe more like in a cookie mode today. So I actually had a serious intention of drinking wine today, but then it's such a sunny day and I didn't have any breakfast yet. So yeah, I guess it's a cookie mode. I have cookies in the shape of heart. Oopsie. Yeah, so let's get started. Enough of that. 3 minutes. Poland. Yay. Nice. I guess everybody in the States are sleeping today because it's like 3 a.m. usually there in Texas. All right, I'm gonna switch the screens. This is gonna be the website I'm gonna try to replicate today. It's been on my list for, I don't know, 1 or 2 years already, because I've seen it and I thought like this is a really fun effect when those dots are traveling through the streets, and it's pretty cool. There's some minor 3D rotation, but this one is the usual stuff. But I mean, I liked the dots look and I like how they travel, and I wonder like how would they do this. So I was fascinated by this website. I think it's done by Red Color Agency. If you go to the menu, yeah, designed by Red Color. It's a Russian web agency, and kudos to the developer. It's really nice solution he found, and we're gonna try to replicate that solution today with Three.js, and it's just a little bit of math. It's really a little bit of math. It's not even sign functions, it's just simple arithmetic functions, but still there's some math here. Anyway, let's get started. So we're gonna do the Vault replica, and we're gonna check the usual Three.js template that I have. It's shared with my Patreon, so you can go to the 40-second stream and you can get that code there, like coding it in 10 minutes. And yeah, let's get started. Vault replica. I'm gonna open the Visual Studio. I'm gonna run parcel. I'm gonna do the layout. This way. Brazil. Well, I believe it's gotta be night in Brazil too right now. It's like 2 or 3 a.m., right? It's next at 3 a.m. Oh gosh. Well, I'm guilty of that too. All right. So we have the template and we have this website. How do you go about decompiling? Well, first of all, the thing that fascinated me the most, and which turned out to be the simplest one, is actually how do those dots know where to travel? Like they are just following the real map and the streets, and I thought it's kind of fancy WebGL. Well, it kind of is, but not that fancy. The genius solution is actually simple. So if you go into the source code, you'd find the SVG, and I just get that SVG. So this is an SVG map, This is still a WebGL animation, but we're gonna get this WebGL, we're gonna get this SVG into the source code. So I'm gonna insert it right before the app.js, and you can already see the, like, I'm not Sherlock Holmes, but this website has been done by a Russian developer, definitely. Okay, and then we have the SVG, and SVG has all those paths, and actually we could just do something like this to investigate this SVG. No, just save it on the desktop, SVG, like test SVG, the desktop. All right, and then go to Figma, because Figma is, like, I believe, what? Okay. Figma is the best way to edit SVGs at the moment. So if you open up this SVG, well, if you open up in just a preview, it's like hard to see anything there. If you zoom a little bit, and that's because those paths are being filled, and this is why we see like shapes instead of actual paths. So, but this is actually a set of dots following some path, and those are actually the paths that you see on the WebGL map that follow streets and the stuff. And well, each of those, like if I select the different one, is just a number of dots that follow the path. So what they did, actually, they had this JPEG, and then they just draw an SVG map of streets over that JPEG, and they had this SVG with just the street maps, just picking up manually random paths across the city. How do you hide the sidebars here? Well, oh, I found it. No, you can only make it whiter, right? Well, anyhow, I think you see the point. So just the paths. But how do we use them inside the WebGL? How we do this kind of interactive, nice dot animation? Well, let's start this journey. It's gonna be a Three.js journey, just like the Bruno Simon has now. All right, I'm gonna go to app.js, and obviously we need particles today. So I'm gonna switch to particles shader, and then I'm gonna open the preview. It's working all right. Yes, it's happening in real time. Well, of course I've looked into this website. I'm gonna be it's just plain crazy. I can do this. Actually, I can do this, but it's gonna take more than 1 hour, and I don't want to bore you with that, because of course I looked into the website before. I figured out the ways to do this in 1 hour. So I would still make a lot of mistakes, but anyway. Well, I closed Figma already. So we have this. And then, well, let's build the data. So let's please get data. Maybe I'll make it a little bit bigger. Get data. And then I would just start by querying my SVG, right? And if you look into those SVG paths, they all has the same class name. It's CLS1. So they all CLS1. I think it was 20 or around that number of them. But let's just count them. All right. Well, thank you guys. I will now know the shortcuts. Yeah, maybe. But I'm not like trying to get the most number of people. Where was I? I was trying to get my SVG. So I'm gonna get those SVG by the class names. So I'm gonna do the document query selector all, and then CLS1. And then this one returns me a node list. So I actually need to convert this one back to the array, so it's easier to work with this one. So this log, this SVG is now all the paths. It's 22 of them actually. Each of them is the path. And what's nice about SVG paths is that they have its own API, so I can use it. Right, how do I use it then? I'm gonna just loop through those. I'm gonna just SVG for each path. And then inside of those, I can use the length of this. So there's a get total length of path. And I think it's better to click to the Stack Overflow usually. So if you just query the path, you can then get the length of the path. So let's just see path get total length. And now we see those lengths, and they are, well, quite huge, and that's because the SVG is actually, gotta see the view box. Well, yeah, the view box is 2K by 1K, so it's actually quite big SVG, and those paths are really big, huge ones. And then, well, the length of those paths also is a big number. So we have 22 paths, we have all the length of those paths. Now I kind of need to, well, to use the coordinates of those paths to produce lots of points on my map. To do this, yeah, I do a little bit of React, but maybe just a little bit of Angular in my past, but I'm not really a framework guy. All right, so I need to build some data, some kind of storage for my whole data of all those paths. And I think it's good to build it around the lines entity. Like every single thing is going to be a line, and then inside the lines we're going to have the dots and so forth. So now I need to get dots on each of those lines. So first of all, I need to calculate the number of points. So let's calculate number of points. I could of course fix this because it could be like 1,000 for each line, but because each of the lines is already has its length, so to make it normalized, I think I need to make the number of points dependent on the line length actually. And it should be something like well, okay, let's just save this one to variable len equals this, and then number of points called should be the len divided, because length would mean that we have like 2,000 points on each line. That's too much. Maybe divided by 5, and then we have to round up this value because it shouldn't be the integer. All right, so now we have the number of points roughly, and then we can just output it to check everything is working. And yeah, we have like 500, roughly 300 to 500 points on each of the lines. Virtual points, we don't really see any of those yet. And by the way, I'm gonna just jump back and forth because I created the particles shader, and this means that I could actually use it. It's gonna be vertex, but then instead of creating the mesh, I'm gonna create points, and instead of creating geometry like this, I'm gonna create it like this. And well, points from the capital. And yeah, this is kind of the points, but I need to make them smaller, obviously. Still too big. Yeah, so we got the points now. Well, not the points we need, but still. And I'll also switch to the black background from the start. So I'm gonna do the points white, and I'm gonna change the background to black. All right, so now I have black points. Perfect. Well, frameworks controlling the animation usually. But anyhow, I think you're having your own conversation at the moment. All right, so we have black dots, and I need to jump back to my data creation. So I have number of points, and then I should actually produce those points. And there's another API for the path, which is get point at length. When I have the length, and this length is something between 0 and this get total length, so I can get the actual coordinates in XY terms, coordinate inside this SVG path. More Angular, all right. I'm gonna create some Angular variable maybe. Come on, stop arguing, guys. All right. So I need to produce the points. For this, I will create the loop, and then until the number of points, which is the integer value now. And then I need to produce some value like point add, which is going to be the len multiplied by I divided by number of points. So this value is going to change between 0 and the total length of the path. So now we can just get this point. We can actually just do the let p equals path get point at length, and then this point at thin, and then we should actually get something here, log p, and let's see what we're getting. So we're getting the svg point object, and it has xy coordinates, so it's kind of perfect. So I can actually do the, so for each svg path I'm going to produce something like the line array, and then this line I'm going to push should I ban? I think I should make you one view of the moderator. All right, so now we have the line with the coordinates, and I think it's going to be px, py, and then just 0, the last one z, because the dot's going to be on one z0 plane anyway. Right, so it's px, py, p0, and then I had these lines. So these lines push object, and then, well, I could produce the ID, which is going to be some index j. Then I could have the path, which is going to be the path that I have here. Then I could have the length, which is equal to len, and then I have the number, which is equal to number of points on this exact path. And then I have the points, which is just, well, actually this should be the points. Makes more sense, which is just the points. All right. All right, so we have those lines. This is the data that we're building inside when we loop through all the SVG paths. And then let's just see what's inside. So we have an array, and it has an ID, the length of the path. And let's just check the points. And we have some coordinates now, so we have some numbers. Well, obviously, I want to use those numbers to produce the points on my screen. So let's just go ahead and do that. So instead of plain geometry, I'm going to do this buffer geometry, my favorite kind of geometry. And then I need to, well, I obviously need to create an attribute for positions. How do I do that? Well, these positions equals an array, and then these lines for each line, and then line points for each, and this is going to be the point, and then these positions push px, py, pz, which is just 0, but anyway. So now we're going to have all positions of all the points that are generated through the SVG in this positions array. And then I always forget how to do this. Buffer geometry. How do you set the buffer? So it's got to be the float 32 array, and then so we're going to set this geometry set attribute position to 3 buffer attribute, and then I'm going to create the float array right here and put these positions in there. So this way I'm just replacing all the positions with these positions, and it should do the job. Should it? What do you think? Should we finally see the particles? We don't see anything, and because geometry is not a function. This geometry set attribute is not a function. Why? It's not a buffer attribute, obviously it's buffer geometry. Alright, no errors now. We don't see anything. Well, that's probably because if you look into the actual coordinates, they are quite big, like 200, 1000. They are really huge, and this means my camera is like 4 units away from the 0, point. I don't know, people asked about muting him. I just muted just for a while. I don't know. I'm sorry, Victor, if I muted you accidentally. I was just too distracted with coding. Anyway, hope you're not offended with this in any way. So yeah, now I have a camera far away, but the particles are quite small still, because I changed the, yeah, you could see them already, and they shifted like far away. So I guess I need to play with the camera too. Camera. So like 100, maybe 10,000. Yeah, you're not alone. So now we see all those particles actually. They're being created, but they all shifted to the right point of the screen. And this is because the SVG has a view box and system coordinates like 1K, 2K, which is starting from 0 and going positive. And I should just normalize them. And to normalize them, because I already know the size of the SVG, I could just do like minus and half of the width, and so now we have it centered on my screen. So now we have all those dots centered. This is already huge. Make the dots much bigger. We have to set the pretty big value here just to see them on the screen actually normally. And this is because I need to eat a cookie, I'm sorry. This is a cookie break. Oh, thank you guys. Nobody is a moderator, but I could make one. I don't know. All right. The cookie break is done, I believe. There's a lightning change, so lighting change. I gotta make it this way so we don't really see the green screen. All right, let's continue. So we have the particles, we see them, but it's way too many of them. So if you just check the number of those particles, let's check the number of those particles. How many of those do we have? So it's somewhere here. If I just actually output log this, the size of this one, and also I kind of want to comment the length and the number of points. So it's actually, well, divided by 3, but still this is going to be like 7, 8 with something thousand particles, and that's a lot to animate on CPU. And the nice thing in the first life hack that you see, that you don't really see like 6,000 or 5,000 particles on your screen. Well, to be honest, at most you see a couple of hundreds of those. And this is the cool thing, because you can actually optimize. We don't really need to render all the particles at the same moment. We just need to render those. So next step would be, let's do the next step first. I'm gonna change the look of the particles, and then we're gonna do the actual animation, like so they travel through the streets. So you just don't see those particles on the screen, but they actually travel through the streets. And this is gonna be like the most math part of the stream, that kind of traveling, because it's gonna involve multiplication, addition, and the model operation. So that's a lot of math to handle. All right. the look of the particles. Let's start with the look of the particles. Well, because I already have this attribute for position, I could actually add another one. Let's get to it. I could actually add another one. I'm gonna call this one opacity. It's gonna be just linear. It's gonna be this opacity. Just to add some randomness to the particle. Oh, hi to the Mexico. ¿Cómo estás? Yeah, I'm creating randomness, right? I need to remind myself what I'm actually doing. So when I'm creating those coordinates, actually I need exactly the same amount of pushes to the array as I have here. So this opacity, push something random. And then I could use this randomness in my, oh, come on, where did you go? In my shader. And by the way, maybe camera should be a bit further, like, I don't know, 600. I think it's better. All right, and I'm gonna use the randomness. So we have the attribute, float opacity. Obviously, I need to get it to the fragment shader, and I need to use V opacity. So I set it here, V opacity, and then have V opacity here, and then I could just multiply. And we already see something random. It's actually looking pretty nice. I like this merge of the chaos, like the randomness of the opacity, and then the order, because they all follow the street map. And well, it looks cool already, but it's gonna look way cooler in a couple of minutes. All right, about particles. So I believe I need to make them way bigger than that. So we have them like 1000, maybe 10 times bigger. So we have the particles with the different shades of gray, like not even 50, but much more shades of gray. And what I want to do next, I want to set some stuff, usual stuff for particles, so they will look better. That's true. Yeah, Bruno Simon just launched the beginner course about Three.js, but I'm thinking of my courses too, obviously. So now we removed the depth and depth test and depth right, so they all rendering like in the same spots. And if I just change the opacity now for the particles, we're gonna see something. Whoa, hello to Chile. We're gonna see some overlap, and I'm gonna see some kind of bloom effect, because when you look at this website, it's kind of that they use some post-processing to make those particles like flare or something, to make them bloom. And they actually didn't. So it's done without any post-processing. So, well, they use in post-processing, but not for the particle bloom. Again, let's get to the actual stuff. So the usual thing. Do we have a date for your course? Oh my god. Do you want me to tell you some date and then being stressed over that deadline? Well, I think I'm really going deeper into this in the following 1-2 months. So you're going to see more content from me in following months. Maybe less streams, because I'm going to be on the shitty internet for some time, but definitely more content I will produce, more other kind of content. All right. Just let me code a little bit, and then let's just make some Q&A session in the end. I'm going to answer all the questions possible, because it gets really complicated sometimes to concentrate on some stuff. Some stuff is simple. Some stuff that I do is simple, but some requires some thinking, and then I'm getting lost in my thought process. So maybe like I'm going to have a break in the end, or before the end, I'm going to answer some questions. So first of all, I'm going to produce some UVs for my particles and the usual stuff. I mean, the particles they don't have UV, but we can do the UV like this. We have the GL point cohort, GL point cohort, and we can just do it like this. I'm not sure if we need this normalization, by the way. They used it, so I'm gonna just replicate it for the sake of UV class vector. So we have those UVs now, and if I just output it, so we're gonna see UVs on each of the particles. Well, kind of UVs. If I set it 0, it's more like UV look, the greenish with the reddish. Yeah. Right, so now we have UVs. When we have the UVs, some system of coordinate, I can actually produce some circle. So this is the usual thing to do this circle. So first of all, I need to normalize UVs, like centralize them. So the central UV is going to be just the UV2 multiplied by the UV minus 1. So now this number is between 0 and 2, and this whole number is between -1 and +1. Well, there are lots of ways of doing this. I could just have subtracted 0.5 actually. I don't know. I don't think this is really that important at this moment. So then we're gonna have some calculations to produce. Well, the usual thing is you just do the float disk equals length of the CUV, and then you can just output it. I'm gonna see some kind of this stuff, and you can just do 1 minus this, and we're gonna see these kind of circles. And this is also a way, and I think it's totally possible to do the animation we are doing today with this way, but the guys went a bit the other path, and I kind of like it because it gives you more control over the size of the particles. Oh, come on guys, stop that. I'm gonna ban everyone who's participating in the discussion. All right, so length CUV. So they went for the different path. So they went for this kind of path. So they created the new... I'm a scholar myself. Я школьник сам. Прекратите херню писать. Чего вы ругаетесь? Мы же просто пишем код. Okay, vec3. Actually, I want to make it the full color. So in the end, I could set this full color to GLFrag color. Come on. I hope that was the cause of the whole discussion thing. All right, so we have this color default by 1, so it's just white. Every channel is white. And then what do we do next? So they actually, I think I was thinking too much about the discussion and we actually kind of can go the other way. So I still produce the vec4, but they went for this. They went this magic number, and I don't think it matters much. We could change it later, and then they divided this by length CUV. So this number is between 0 and like 1, yeah, and actually 1, and square root of 2 actually, yeah, inside the particle it's actually between 0 and square root of 2. But then if you divide any number with something close to 0, you're gonna get infinitely big number, right? So this color is now going like infinitely huge, and then when on the edge of the particle it's just small. It's gonna be 0.08 and divided by 1, and it's gonna be just that small value, right? So it's gonna be still kind of dark, so we wouldn't be able to see anything with this setup. But then they just multiply this stuff, and the reason they do this, you'll see it a bit later, why they actually do this. So they color RGB, we're taking the minimum so it doesn't go over the some number. Could be any kind of number actually, it just changes the type of the look that we are getting. We are coding this animation that you see on my screen now, and By the way, you could just go and see the URL. All right, so we have those particles on the screen now. Now we need to make a look and then animate them. So when we divide this color RGB, yeah, now we should normalize it. So it doesn't go, the infinitely big number doesn't go over 10, let's say 10. So it's gonna be color RGB. So it's gonna take the minimum value of those two, and it wouldn't go over 10. And then they actually using some like some number for the color. Float color is gonna be X3. It's actually kind of good practice to encode RGB colors inside the GLSL is just to set the RGB values and divide them by 255. And it's gonna be 10 divided by 255 and 20 divided by 255. This is a bluish color that you see on their website, actually, like the color that you see. We could have used any other color. Maybe we will change it in the end of the stream. Well, I'm sorry. It's going to be hard to answer all those questions. All right. It's shader language. It's just shader language. So we have this color. I believe I have some error now. Or why do I don't see anything? Some shader error, dimension mismatch. Oh, because I'm setting float color, and this should be original color, maybe original, something like this. 107. Should have been divided. Why it's comma now? Yeah. I should have divided like 0.8 by the length of the UV, because well, everything I explained was based on that. So we're dividing something with 0, well, almost 0. So we don't see anything changed yet. And even if we, well, let's just output the original color for a second just to see if it's working and what color is actually that. And it's kind of bluish, it's dark bluish, but we're going to be multiplying this color with something, so we're going to see the blue. Yeah, it's a graphic programming mostly, not React, sorry. All right. So there are going to be a couple of magic kind of multiplications, but then in the end you're going to see that you could actually achieve this with a smooth step. But I'm still interested to replicate the exact way the developers used, because you gotta learn some new ways to do the same thing. So I think this could have been done with 2 smooth steps also, but still. So we have this math now, and then we gotta involve the actual color now. So color RGB, we're gonna multiply this one with the original color. So because this now has all the same values, like it's gray, it's RGB channels all are the same here. So I'm going to multiply this with the original channel and some big value, because it's too dark, you know. And I think the 120 worked good for me. And then I could just I remove these. I set the color RGB here. Yeah, and the color starting to look, well, kind of like the color that we get here. It's not yet clear why we have this square stuff, but we are getting there. So now we have this color RGB, and the thing that we need to do, I'm going to multiply my whole color with the opacity value to randomize all the things here. So now we have those things random, but I also need the transparency of the particles, because right now they are not transparent at all. We have the alpha channel set to 1 the whole time. So I'm going to do another calculation with my opacity part, and it's going to be, so it shouldn't go over 1. So the color still has some alpha now. Maybe multiply it with 10. So we are getting there. They already square root, they are kind of bright. Not quite yet there, and I think the reason is I gotta make it bigger, make particles way bigger than that. Now they are overlapping. Did I actually send transparent to true? I did. Oh, and then I need to set the blending part, because blending looks cool on particles usually. Now we have them bright because they are just adding the additive blending, they're just adding the color. But then I think I just need to set the value in a different scale. I mean, the opacity I'm setting here, I'm spending too much time on the look, maybe divided by 10. Yeah, you see what we're getting now? So maybe by 5. So if you play with those values, you could get all kinds of looks, and it's not even post-processing. They're just additive blending, and the particles are huge again. So if you just get back, you see them small on screen. But if you just get back for a moment and make them, I don't know, white. I mean, white. You could see the squares. The squares are quite big of them. But if we just do this, so the particle is big, but it has this flare, it has its brightness. And because it is additive blend, then you get this nice look. And with randomness, I think it looks already pretty cool to me. So I need to drink some water. Sorry, you keep on doing this stuff. Sorry, Victoria, because I'm not sure if you're Victoria now. All right, so you could see those particles. You could actually see the edge, even the edge of those things, if you make them brighter. But anyway, let's continue. So now we have those particles in place. They look cool. And then we need to make this animated. So first of all, let's get back to the array we have. We have 22 lines here, 22 paths on my screen. So what I need to do, I need to animate them all separately. And I need to animate them all in my render loop. Also, I don't need all particles, like one of them has like 500 particles, another one has like also 500 particles. I don't need 500 particles on my screen. I actually need like 50, maybe 100. I think the guys used just 100 particles. So I just need to see the trail, just one trail to see on my screen. Now let's implement the trail. So I'm gonna do this update things. Update things. And instead of doing the geometry where I do like all the particles on my screen, I'm gonna do just 2200 of them, because I already had what? Oh, this is because it's the other website. I'm just gonna do 2200 buffer geometry. So it's gonna be, I'm gonna be using just 2200 particles on my screen, not those 10,000. So let's try to do this. So instead of doing this, I'm gonna do like this max equals 2200. Or actually, this could be this lines length multiplied by 100. And then I'm gonna do the loop max. And then instead of these loops showing all the particles, I'm gonna do this opacity. Well, actually the same line. I'm gonna do 2200 of them. And then the same goes for the positions. But I can actually push just 0, 0, 0. Like, which 2200 should I put? Because we see the different particles on my screen the whole time. So I could actually push just zeros for this, well, at this moment. And then let's see. Well, maybe math random, just to see them. And the same here, just to see something in my screen. Okay, something broke down. Max is not defined because it's this max. So we see those particles, and it's actually looking kind of good. You see, with those particles, you could achieve lots of different looks, and this is magical looking particles. And then let's continue. So we have particles with random location. They are not following any paths. We just, well, commented actually all the connection between paths and that stuff. And what I want to do actually, so I have those like 100, I have 100 reserved particles for each of my lines. So when when the time goes by, I want those particles to, I want to see only particular 100 particles from each of the lines. And for this, I'm gonna just do this. I'm gonna update the attribute and like Three.js update attributes. Where's that? So to update the attribute, you just get the array of this attribute, which is the float 32 array, and then in the end you just set this. So because I already have this geometry, I just need to update it like this. Needs update true. And then in between I need to change it. How do I change it? I'm gonna set it first. This position array equals this position, because this position is already a 32 array. I believe so. Is it? So this positions is not yet 32 array, but we can do it 32 array. I could remove the remove it here now. And actually, when I'm setting, instead of push, I'm gonna use the API of 32 array, which is set these values and I multiplied by 3. And well, probably the same goes for the opacity. I'm gonna change them both like this, right? And instead of push, I'm gonna use set. It's gonna be an array, and then oopsie, and then it's gonna be I, right? So it shouldn't change anything. Well, it already changed something. Offset is out of bounds. I guess I have to set the size of the arrays right away when I initialize them. So it's going to be multiplied by 3, and this is just this max. Bytes per element of undefined. Okay, I guess this is because I'm setting those values. Right, so back to something working again. So we have this position, which is actually this positions, which is 32 array that I initialize, and I could actually, this should work, right? Yeah, so just updating with the same values on each request animation frame right now, and nothing's happening because I'm running it in my render loop. I'm updating it with the same exact value every time, and nothing is happening. So now I need to change these positions inside this loop. So I'm going to do these lines for each, and this is going to be line. I also need to have some j equals 0, some index. Right. So now I can get the first 100 points of each of the line. So first of all, for each of the lines, I need to have some speed. I need to have some current position. So let's set those values. Let's set those values. 0, speed equals, let's say 1 for every single one of them. And then it should be enough. So now when I see first 100 points of each of my lines, let's try to do this. So this is looping through all of the lines. I'm taking first 100 points, I'm going to push them to these positions, and I should see them. This is the plan. like 100. And then, so I have this line, the line has points, so I could actually, okay, so the point is going to be line points I, so this is a vector 3, and then I'm going to have these positions set. I'm going to px, py, pz, I multiplied by 3, and I runs from 0 to 100, so it's going to be first 100 points. But it couldn't be, it shouldn't be I, because if it's I on each of the loops, we're gonna set first 100 of positions. This is gotta be this J. It's gotta be this J, and let's see. So now we have first 100 points of each of the lines, and just so you understand what I did, because if I just replace it with I, I'm gonna just see one line here, because only first 100 of positions being updated and all the others staying the same. So I just need to do this J here. So now I need to make it move, right? And to make it move, I need to change the current position of my line. So on each of my update things, for each of the lines, I'm gonna change the current pos. I'm gonna add the line speed, which is just 1 at this moment. And if the line speed, the current position goes over the length of my line, so the current pos should be equal, I mean line, it's not current, it's line, I mean not this, it's line. So line current pos, line length, so it shouldn't go over the edge of what number, for the maximum number of particles that we have. Okay, all fine now, because I'm not really using the current position yet. So now when I'm getting this point, I should actually involve current position somehow there. So I'm gonna produce the index, I'm gonna use this index there, and the index is gonna be equal, what? It's going to be line current pos plus I, because well, it used to be just I, and now we're just adding the current pos, but this could also get over the maximum amount of, or the maximum number of particles in my array. So I need to do the same thing here. I need to make it modulo length. Well, you don't see anything because property x of n defined. So probably I'm still going over the edge somewhere here. Line length. It's not line length actually. Length is the length of the path, right? It's not actually an integer. We need to use the number of particles, which was, what was the name of this? Just number. I need to use number, not length. Well, in my head it was length of the array, but it's actually just number. Okay, still something wrong. So we are getting some index here, which we don't really have in the array. Let's just output it, the line here. So the current pos is actually none. What the fuck? I mean, Amita Vitto. Yeah, I could have used that also. Yeah, it's a nice suggestion. But so current pos is none, and this is because why? Because it's this. Yeah, and now you see this because we're moving and we're looping on each. Okay, I have to remove the console log line. This was the hardest math part, the whole stream. So now because the index is growing all the time and because it's modular, we just haven't looped paths all over the place. Jumalauta. Okay, so we have them traveling now. It's not yet like what I wanted to see, but we are getting there. So now we are setting the positions. So it's kind of good in terms of positions, but we still have to set the opacity, like, so it's like fading away. So the trail is fading away. So we do the opacity, and I'm gonna set the opacity, you know, the closer it gets to the head of the thing. And you know, we have this number like from 0 to 100. This is actually from trail to the head of the, I don't know, what's it out? That's kind of snake traveling through the screen. So I could just set the opacity, also J, to something like I divided by 100. And maybe by 1000, because I used to have this opacity like divided by 5, so by 500. Let's see. And now we see it already. Well, it's kind of it. I think we almost made it. We have to add some randomness also, but we just did those traveling things. So what we need to do next, we could just show the image behind. This is actually JPEG, just a JPEG image that you used as a reference to build all those SVG paths. So we could use this image and just show it behind. And then, well, we could play with the numbers also, maybe 1000 in the end. So it looks more like we should add some randomness to the particles also. So when I create the coordinates, I could actually do some randomness. I mean, that might be too big. But just a little bit of randomness adds to this whole look. So now we have them like this. And well, this is kind of it. Well, let's just try to also show the image, and this is going to be the last part. Gotta guess which image we're going to show, though. Let's just see what images are they using on the website. I think it's one of these. And it's also multiplied, I believe it's also multiplied with the background color, so it's bluish. Let's try to guess which image do I see here right now. No, I think it's the first one. Gonna go to Vault Replica. JPEG. I'm gonna just use, I think I'm gonna use just mesh basic material. So we have this image, and I could just add the mesh basic material with the color here and with the map. So not here, but like here. So let's okay, let map equals new 3. New, just the last touch. It should be 248 by and then new 3 mesh basic material. I don't know, blue, and then map. Alright, so just real fast created the mesh for me, this scene add map. Can resolve dependency JS image JPEG. JS image JPEG, alright. Something is wrong. Blue is not defined. Of course, blue is not defined. Still something is wrong. Image is not defined because it's just image. I have to be more consistent with. Well, I guess it's not the. It's not that one, or maybe. I think it's a flip. Yeah, I think it's a flip Y situation. So I need to create texture equals this. Yeah, so now we have it. Now they are really traveling those street paths. And I think, well, of course we could, we should play with the color definitely here. Maybe just make it a bit darker, should be enough. Oh, you get the point, I guess. No, that's too much. Should be enough. We could play with the brightness and the contrast values. I think they used the separate shader material just to show the map and show, because they also have this like a little bit of lighting for the street parts. But this is already quite simple. So now we have these paths, they have these dots travel in the streets of the city. And this is really, well, I think this is amazing. This is kind of a magic to me, even though on the other hand, it's kind of a simple, pretty straightforward way. So we're just setting the positions of the visible points on my screen. But in the end, it's just, well, it's so cool. It's just so cool to look at, so mesmerizing. It's so simple to produce. You need to, of course, use the Figma or the Illustrator to draw all those paths. But, you know, it's quite easy. You just see the image and you just connect the points. I mean, you don't have to be a designer to do that. Any developer can do that. Yeah. So as I'm finished with today's animation, we can have like questions, because I probably missed some messages. Yeah, you're trying to help me. Thank you. Yeah, I think it's Z position, because when we rotate, it's a slight Z position thing. So just moving the particles in the Z axis, and that's it. And that's it. This is not that, you know, mesmerizing, so I wouldn't do that, but they're just moving the Z and the value. Right. Oh, thank you. I don't think I'm that talented. I'm just learning new stuff. Yeah, it's really cool. And by the way, I actually promised to change some variables, just so we see how it looks with the different settings for the fragment share. So we could just try to play with these values and do something like this, which is, well, something different already. And then maybe multiply by 100 here. Okay, this is not good. Something like this also, which is like kind of more bloomish effect, which is, I think, might be even cooler than what I've seen on their website, actually. I like it a bit more. Well, both of them look cool. So it's plenty of experimenting here, and I really like this kind of bloomish effect on the particles. Well, I could actually do also, like, the first thing I'm thinking, it's here, they now linearly fading out, so I could just do, I could square this. So I could do math, pow, like to the second power. What? Oh, because it's that small, and then when I raise it to the power, maybe just... Okay, now it's the same, maybe like this. So now they kind of fading like not the square root, but 1.3 square root. I mean, I could get back to the more brighter option here. Yeah, it's also kind of cool. Well, it just everything that we do here is actually pretty cool and could be used in any design. Hue and saturation of a clock. Well, of course I can, because I have this opacity thing, so I have this V opacity value. So I could actually do how do we do this? How do we do this? Do I need some HSL, JLSL function for that? We could do like the this is definitely the last thing I'm gonna do today. We could do this. I'm not even sure how it would look like, and I haven't even really tried that on this particular example, but well, let's try to do this. The palette, where's the formula? Okay. So actually this original color is kind of the color that we're getting here, and maybe if I do this 40, I'm gonna get the completely different look. So instead of this original color, I can use something dynamic depending on the opacity maybe. Or because opacity is changing between 0 and 1, I could just maybe do something like this. And then I don't know, just some random numbers. Maybe it will look nice. Probably made a mistake. Still a mistake somewhere. Okay, 10. Should have changed the color, probably because I'm making them too bright. I'm losing the color here. So what I told you in the beginning, that you actually could achieve this effect with two smooth steps. One smooth step for the bright part of the particle and another smooth step for the other part of the particle, for its flare. And I think it would be easier to change colors and hue saturation with those, instead of just using this like really dark color and then multiplying it with the big values just to get some bloom effect. So this is a different look, so I think this might be a different animation, but this is the way to do this. You could just play with those values and do the smooth step. Yeah, maybe also multiply this by 100. So we're getting the different colors, but not enough different somehow, right? I don't know, maybe. So we're just getting one color in the end. The opacity doesn't change much. Maybe should I multiply it with a bigger number? Just to make a gradient of some sort. Well, because the opacity is between like some small values, maybe I could just, I don't know, maybe we should just stop. This is just, you know, you could experiment with this infinitely. So it's going to be a homework. Try to do the animation. So I think you should just do the smooth step with the opacity and then mix colors, like multiply this color RGB with some different colors, and you'll get it. Just a different math, and maybe I will do a mistake, and we're already over 1 hour, so probably should stop and get a nice Sunday, everybody. Yeah, just go ahead and try it. I already broke this piece. Okay, I'm just gonna get back so I have a nice version of this animation. Purple, yeah. I don't remember which number was there, by the way. Oh, it was 4 there, okay. Yeah, so this is the animation. Thank you everybody for being with me today. I don't think there's going to be stream next Sunday, so it's going to be a short break and then we're going to get back. Hope you like that one. Let me know what you think. Also leave some comments. I really appreciate it, and it helps to promote my streams, my videos. And well, yeah, push a like button, subscribe, comments. Thank you for being with me. Thank you for supporting me today. Yeah. Have a nice Sunday, everybody. And see you in the next stream. See you on Twitter. See you everywhere. Also, if you're still here, I have a Russian course now for junior developers. So if you're interested in those kind of things, you could go ahead and run it. It's still in alpha, beta, but I'm gonna be keeping you updated. I'm gonna be updating new stuff in there. This is mostly for junior developers though, so not for Three.js fans, no, not for the WebGL. But anyway, so guys, thank you. I believe I should change this background now. Have a good day, everyone. Have a nice Sunday. Say some kind words to the people that you love. Live a happy life, and see you.